Hi everyone, hope you're all doing well. What I want to do in this video is go through some resources that can be very helpful for anyone who wants to try doing some science experiments for themselves, which is something that I would strongly recommend for anyone who has an interest in science. I've talked in previous videos about how science is based on proposing and testing models of nature, and that when a model or claim is presented, the only thing that increases our confidence that the model is correct is whether or not it accurately predicts the outcomes of physical observations and experiments. In science, there are no authorities that declare from on high what is true about the natural world. It is observations and experiments that determine what we tentatively accept as accurate, and it is observations and experiments that we use to demonstrate when a model fails and must be discarded. So while science does have experts, people who have spent a lot of time and effort in setting up those experiments, making those observations, analyzing the data, and applying those scientific methods to reach the most accurate current conclusions, those currently accepted positions are still ultimately based on the data. So for anyone interested in science, learning a bit about how to actually do an experiment and analyze that data is critical. And the best way to learn is by doing. In the videos that I've posted on this channel, I've talked about a bunch of different physical principles, but you shouldn't believe me, or at least you shouldn't just believe me. You shouldn't take anything on authority because authorities can be wrong. In my Scientific Critical Thinking and Testing Physics series, I've tried to demonstrate some of the methods involved in how to set up actual experiments, take real data, and then analyze that data to test scientific claims. And I hope I've done that in a reasonably convincing way, because again, the conclusions that we reach about any claim should be based on actual data. All these steps in setting up an experiment, making observations, doing the analysis, all these can be quite complicated. So there's no better way to learn these methods than by trying it yourself. Unfortunately, one of the challenges is that experiments require accurate measurement tools, and these can get pretty expensive in a lot of cases. We definitely can't all get space-based telescopes or massive particle accelerators to do these kinds of experiments in our backyard, but there are actually a lot of either free or fairly low-cost resources that are pretty widely available. And it's these resources that I want to go through now. Please note that this is not sponsored content in any way. I do not get a dime from any of these companies that I'm going to be talking about or any of these resources that I'm talking about. These are just some resources that I've used with students in the classroom and found them to be pretty effective and useful tools. The other thing I should mention before we jump into these resources for science experiments is that in any experiment, safety comes first. When my dad was first teaching me about how to approach a job site where hazardous equipment was being used, he gave me a list of 4 objectives. Don't hurt yourself, don't hurt anyone else, don't hurt the equipment, get some, we'll just say, expletive work done. And I think the same applies for doing scientific experiments. And while I'm not going to be mentioning any inherently dangerous equipment on its own, we want to make sure that any tools we're using are being used responsibly. So when I talk about using your smartphone as a pressure sensor, don't put it underwater to measure how pressure changes as you go deeper into water. Or if I talk about the accelerometer on your smartphone, don't use that while driving in a car or anything like that. Make sure that you're not risking yourself, anyone else, or the equipment, and only when those objectives have been met, then we can get to doing some science. So let's have a look at some of these resources. Modern smartphones have a whole bunch of different sensors automatically built into them. Okay? Again, exactly which ones your phone has might be, depend on the brand or the model of smartphone that you have, but there are some apps that we can use to get access to these different sensors. There's the Phyphox app, and I've got links for both the iOS version and the Android version. And there's the Physics Toolbox app, again, both for iOS and Android. I've included QR codes, so if you want to look those up, they're available. And let's have a look at some of these resources. So this is the Phyphox app, and it lists a whole bunch of different individual sensors for a whole bunch of different kinds of experiments that you can do. And let's just talk about a couple of these. So, for example, the acceleration sensor. Okay. If I start this, I can measure how the phone is accelerating in 3 different directions. So if I just put this on the table, then there should be almost no acceleration. And when I'm holding this thing, I can test whether I'm accelerating in the X direction, side to side, whether I'm accelerating in the Y direction, up and down, or the Z direction, forward and backward. So how I move my phone, it's going to be able to measure how much acceleration I have in each of those directions. And again, in all these apps, there's different ways of kind of displaying the data. Once you've taken the data, it is possible to export that data to an Excel file, get access to that raw data. But I do think that in a lot of cases, in a lot of experiments, if we go back to a graph like this and reset this, I can basically just read off the graph, well, how much acceleration do I have in these different cases? So again, we've got acceleration sensors. We can look at the gyroscope that's in the phone. So again, we can measure what is our rotation rate in different directions. So notice that as I rotate the phone in different directions along different axes, well, that determines which part of the gyroscope is going to be measuring that rotation rate. So again, we can do experiments with rotation. Let's leave that. You can use the camera as a light sensor. And again, depending on the exact brand of camera, the exact brand of phone, these resources can be a fair bit different. So you always want to test out these different sensors before you jump into a full experiment. But just as an example, if I start this light sensor, if I aim my phone towards the light in the room, well, that light sensor goes up quite significantly. If I cover up the camera, this one seems to be using the front camera on the phone to measure that brightness. As I put my hand over it, that illuminance goes away. So we can do experiments saying, how does the brightness change as I get closer to or further away from a light source? We can make a pretty quick experiment like that. Okay. There's a bunch of other sensors. Let me switch over. Instead of looking at the Phyphox app, let's change over to the Physics Toolbox suite. Okay, so again, the Physics Toolbox suite, again, just uses pretty similar sensors, a little bit of a different display. But again, there's a whole bunch of different sensors in here for measuring different kinds of motion, using the microphone on the phone to measure different parts of different aspects of sound. We've got the light meter. Some other ones on here are the pressure sensor. Okay, so right now this is measuring the pressure where the phone is located. And if I hold this phone higher in the air, well, higher up in the air, the pressure goes down a little bit. If I move this phone closer to the ground, well, the pressure goes a little bit up. The higher you are in the air, the lower the pressure. Lower down you are, the higher the pressure. So you could pretty quickly make an experiment out of that to figure out, well, how does the pressure change with the height in the room? Okay. Or if I do things like open the door quickly or close the door quickly, how does that affect the pressure in the room? Okay. We can use the magnetic field measurement. So this is, again, measuring how much magnetic field am I getting along each of the axes of the phone. So if I turn my phone to point it as close to due north as possible, then the X value for that magnetic field sensor should go pretty close to 0. So again, if I'm aiming this north, there should be no magnetic fields going side to side. And notice I can measure not only that there's some magnetic field going north along the Y direction, but that magnetic field is also going into the Earth. So you can do experiments measuring how how is that magnetic field kind of directed into the Earth? So if I kind of aim this down, we can see if I can get all of that magnetic field. And let me aim and find the direction for north again. And then if I aim down, we can start to figure out, well, exactly how strong is the magnetic field and what direction exactly is the Earth's magnetic field going into. We could also do experiments with other kinds of magnets, putting magnets near this thing and determining how does that magnetic field depend on how close the magnet is. Again, make sure you're using these responsibly. Putting a very powerful magnet next to your phone might be a little bit risky, but again, for moderate to small magnets, it's not going to have very much of a difference. Just start with it far away, and if this sensor is going too high, that's when you might not want to move the magnet any closer to the sensor. So again, those are some, just a few of the sensors that are built into your phone that you can use for various science experiments. Okay. Some other ones that I find pretty helpful are related to sound. Now, the Phyphox app and the Physics Toolbox suite, they both have sound sensors in there as well, but there's a couple other ones that I find particularly good. This one, as far as I know right now, it's only available on Android phones, but this Spectroid app is pretty interesting. So if I switch over to this Spectroid app, what this is measuring are the different frequencies of sound that are being produced by my voice and going into the microphone. So along the horizontal axis, this is the frequency of the sound in hertz, the number of cycles per second. And the vertical axis is the intensity of that sound, measured in decibels. And this diagram down here is showing which frequencies are being produced in which amounts at different moments in time. So, for example, if I hum a certain tone, something like doo, it's going to be able to measure not only that bass frequency, let me pause that for a second, not only that bass frequency, but also some of the higher harmonics that my voice is producing when I sing a particular note. Okay? So if I start singing different notes, I don't care about embarrassing myself for this, so do 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 do. We can see that as I sing different notes, well, the frequencies go up, not only in the bass frequency, but also in those higher harmonics, and you could start to look for patterns in which pairs of sounds sound good together, which musical intervals sound good together, and which are more dissonant. So again, there's a lot of things you can do with that. You can do that with musical instruments as well. But again, this Spectroid app is another kind of interesting app where we can use a lot of these resources for almost no cost if you already have a smartphone. So yeah, that Spectroid app has a lot of really cool features for measuring the properties of sound and looking at specific frequencies of sound. And I'm actually going to be using that in a upcoming video. That app and its ability to measure frequencies, use that to actually measure what is the Young's modulus of aluminum, or figure out what the stiffness of aluminum is by using that particular app. So that's going to be in an upcoming video. Unfortunately, that app is only available for Android. As of the time of this recording, I checked the Apple App Store and I didn't see it on there. But there are other apps, some of which have free versions. Some of them you have to pay a little bit to unlock some of the more interesting features. But again, there's a lot of different resources where you can use your phone as a whole bunch of different kinds of physics sensors. But there are a couple other pieces of equipment that are really, really helpful to also have on hand when doing different science experiments. Now, every science experiment is going to have specific pieces of equipment that you need to have. These are just a couple of things that are kind of bread and butter sort of pieces of equipment. So, for example, having a kitchen scale for measuring masses. So, again, I just did a Google search for a kitchen scale, And you can find these kinds of kitchen scales, some with accuracies of around, up to half a gram, some with accuracies down to 0.1 grams. You can kind of look through these, and these you can kind of find for around, 10 to 20 bucks. So not too expensive. Another thing that's going to be very helpful in a lot of experiments is having a spring scale for measuring forces. So if we just do a quick search for a spring scale, again, there's a variety of different qualities that you can find, but you can find a lot of spring scales that'll do the job for, again, in the $10 to $20 range. So again, that's a good thing to have on hand. It's going to be useful in a lot of different kinds of experiments. If you're doing any experiments with electrical circuits, again, always making sure that you're being careful when doing any experiments with electricity, having a digital multimeter, also going to be extremely helpful. So if we search for that, then again, you get a very, very wide variety of qualities of multimeters, but again, you can get some pretty basic ones for around 10 to 20 bucks. You might not need to find the super expensive ones, but yeah, for 10 to 20 bucks, you can find something that'll be pretty good in doing a lot of different kinds of physics experiments. So again, these kind of key pieces of equipment, it's good to have them on hand. They're not extremely expensive, so if you're in, say, a science club or a homeschooling group or anything like that, or if you're just interested in science and want to try some experiments and talk to some friends, get some materials together for that, you can do that at a fairly low cost. A couple of other things for analyzing and graphing data. Remember, we don't want to just do an experiment. When we gather the data from that experiment, we have to figure out, well, what does that data tell us about whether the model that we're considering is accurate or not? We have to be able to analyze that data. And for analyzing and graphing data, I actually have previous videos on how to make graphs in things like Google Sheets. Again, all you need is a Gmail account and you can access Google Sheets. And another program that's pretty helpful for doing this kind of graphing that, again, has a free version. There's a paid version that has a lot more features, but the free version is pretty good. The Vernier Graphical Analysis. Let me pull that up really quickly. And this is really, really good at making very, very quick scatter plots that are used in a lot of different kinds of graphs and applying a number of different kinds of fits to that. So let's say I just have some data X and Y, and I want to really quickly make this graph. So let's say that this is going to be 1, 2, 3, 4, and 5. Let's make the Y values 3, 12, 27, 48, and 75. Then notice this graph basically generates the scatter plot pretty much automatically. And then we can go to graph options and apply different kinds of fits. In this case, let's do a power fit, apply, and cool. We can very, very quickly identify what the best fit parameters are, what that curve of best fit is, and then we can use that mathematical pattern and compare it with the claimed equation for whatever kind of experiment we're doing. And again, this has some pay options. Unfortunately, if you want to do something like a fast Fourier transform, you have to get the pay version. But again, there's a lot of features that are included with the free version of this that can be very, very helpful as well. So the point I want to make with this video is that even though a lot of the equipment that you'd find in something like a high school or college level physics classroom, things like low friction tracks and motion sensors, those definitely get expensive. There are still a lot of resources that are pretty accessible at little to no cost. Again, using your smartphone and the sensors inside of your smartphone for science experiments. And again, a couple of pieces of equipment that are relatively low cost. A couple of things you might want to add to this list. Maybe a slotted mass set. Which, again, some of these can get pretty expensive, but there's other ones that you can get for around $30. Not too expensive and are used in a lot of different experiments. Other kinds of experiments, you might need individual pieces of equipment like spring sets, or pulleys, things like that for different kinds of experiments. But again, some of these materials are kind of the bread and butter pieces of equipment that you're using in a lot of experiments. And in future videos, I'm going to be continuing to go through different kinds of experiments, showing how you can set up these experiments, and again, a lot of them that you can do just at home, and also how to analyze the data from these experiments. Because once we've actually done an experiment and gathered some data, we always need to check whether that data actually matches with the scientific claim that has been presented. So those are going to be coming up in future videos. If you have other ideas on some apps that are useful, some low-cost scientific equipment that you found, especially things like video analysis software. I haven't found a good low-cost option for that yet, but if you have ideas about that, throw that into the comments. Hopefully this was useful, and we'll see you in the next video.